But now we are going to be treated to a talk by Nyah Macklin, who's a senior AI advocate for Neo4J. And she's going to be talking about the GraphRAG advantage. Please welcome out Nyah Macklin.
Hey, y'all. So number one, I appreciate you all for coming. This is pretty much a packed house, so I'm so grateful. So today we're going to be talking about the GraphRAG advantage, providing enterprise-grade knowledge to AI agents and LLMs. So let's go ahead and get started. Well, first of all, how are y'all doing? That's my real question. How's the conference going? Yeah! Love it, love it, love it. All right, so to introduce myself, everyone, my name is Nyah Macklin. I am a senior developer advocate at Neo4J. And I like to also call myself a graph wizard here at the Neo4J team. And my research focuses on graph theory, graph algorithms, context engineering, and GraphRAG, right? So, but my core philosophy as well is to think critically about the technologies that we all adopt and promote, right? So therefore, I also center ethics, governance, strategy, safety, and responsibility in artificial intelligence. So before we get started, y'all already know how we do. We gotta take a selfie, because this is incredible. All right, 1, 2, 3, boom, woo! Love to see it, love to see it. All right, that'll go on socials. Okay, so let's dive in. So who here has heard of Neo4J before? I want to see some hands. Most of the house. I love it, I love it. Okay, so Neo4J, we are a graph intelligence platform, and we make it easy for developers or engineers or leaders who are in artificial intelligence to build agents and applications by providing a comprehensive platform for modeling, managing, and retrieving context, okay? So context is the key here. Context is key. Context and relationships are everywhere. So today's conversation, we're going to serve, and we'll serve as an introduction to graph intelligence, to how to use graph to improve context engineering throughout this concept called GraphRAG, through the GraphRAG architecture. We're also going to go through the benefits and comparisons of graph versus vector, because I know a lot of us are vector enthusiasts. Vector-only architectures is what I mean. And then we're going to dive into some research and some white papers and end with agentic development. Perfect. So if you'd like to have a more in-depth conversation with Neo4J about graph or see some highly complex use cases, please dive into it with us at booth 200, which is right in the back. Okay, so now it's time to really dive in. I know, it is hot, y'all. It is hot today. But we're going to have a great time regardless. So first of all, let's start off with this concept, knowledge graphs. So who here has seen or worked with a knowledge graph before? Okay, all right, we got a good number of people here. So who here can explain what a knowledge graph is? A lot less hands, a lot less hands. But just in general, for those who don't know, a knowledge graph is an organized representation of real-world entities and their relationships. So what does that mean, right? A knowledge graph in general is typically stored in a graph database, which natively stores the relationships between data entities. Let's break that down quickly for those who are new to the concept. So we have this concept called nodes, and nodes represent entities within knowledge graph, right? And they're usually things like objects, events, situations, and concepts, right? So relationships, on the other hand, relationships are the links between different nodes that capture the context and the meaning and the information that is being connected. So we also have this concept called properties. And properties, they represent the attributes on the nodes and relationships. So for example, if I am a node, I'm a person node here, and my new friends down here are also people nodes. Hey, friends! So these are my other friends, and so our relationship node is that we are now new friends. So that is just an example of the architecture of a knowledge graph. Nodes, relationships, and then the properties that are on those nodes and relationships. Okay, so A normal RAG pipeline, most of you are so familiar with this architecture diagram, but in a normal RAG pipeline, you are not using knowledge graphs. So in what I would call a normal RAG pipeline, you're going to do something such as take a number of different PDFs, for example, you're going to chunk them, and then you're going to index those chunks using a particular text embedding model. So then, when it's time to query those text chunks, you're going to use that same text embedding model to fetch the top K or the top X number of relevant documents, and then pass all of that information back to the LLM. And then the LLM is going to give you the final answer from those specific documents. So that's a normal RAG pipeline or model that folk are usually used to. But on the other hand, what is GraphRAG? Okay, so hold up, y'all already know I like to quiz the audience. So who here has heard of GraphRAG before? Before today, okay, before today. A few hands, all right. So who here has actually used GraphRAG before today? A lot less hands, but a few. All right, and as I like to do, can you explain it? If you can explain GraphRAG, that's what I want you all to come away with, right? So actually being able to explain what GraphRAG is, how it actually works, that's the key point that I want you all to come away with, and how you can use GraphRAG to solve the problems that you're having with your vector-only architectures when it comes to Gen AI applications. So, like I said, what is GraphRAG? Fundamentally, in its most simple form, GraphRAG is normal RAG where the retrieval path also includes a knowledge graph. Love the pictures, love people taking pictures, trying to get that nugget of information, okay? So GraphRAG fundamentally is normal RAG where the retrieval path includes a knowledge graph, the thing that we had just talked about before. So remember when we had mentioned the normal RAG pipeline illustration that I had just showed before, the normal RAG pipeline does not use a knowledge graph in the retrieval path, whereas GraphRAG does, okay? So when you include a knowledge graph in the retrieval path, you can use graph-based retrieval patterns such as graph-enhanced vector search and graph enrichments. And when people often ask me, you know, Nyah, why should I use graph over vector-based RAG, or why should I use RAG versus GraphRAG? Usually I'd like to say, in a simple term, right? If you're going to answer a question that could usually be answered with a search engine, for example, like find me the lowest sugar ice cream out there, right? Then that could be something that vector-based RAG is very, very adequate to solve for you. But if you want to generate insights from data, right, including the relationship information from that data, then you'll probably need something similar to GraphRAG. For example, if you're trying to do source code analysis, or if you have a supply chain question, for example, or anything that will require the aggregation and concatenation of data from different documents, then GraphRAG is going to be the best solution for you. So folk often also ask me, right, like where RAG with vector-only databases, where RAG with only vector databases often falls short. So some of you might tell me, Nyah, my team is doing just fine with vector-only RAG. If it ain't broke, don't fix it, all right, for those who have heard that term. So here is where vector-only RAG falls short. So vector databases are amazing at some of the art of the possible with generative AI. However, most business applications with requirements that are more demanding, they're going to need a well-constructed knowledge base with multiple forms of search and enrichment. So this eventually requires the expanding beyond just a vector database. So while vector databases can solve some hallucination problems, right, and offer some great source traceability, they have several different limitations. So number one being that you can only leverage a fraction of your data. And I say that specifically, meaning that you can only really use your unstructured data and perhaps some metadata, but not the relationships of your structured data unless you stand up another solution. So like your own graph embedding service. So you also, another limitation to vector-only RAG is that you often miss critical domain-specific context. Remember I had mentioned this context piece being very important. Because you can't use all of your data, because the vector databases just enable embedding search specifically, your LLM applications will miss critical domain-specific knowledge, which can compromise the quality and the effectiveness of business applications. So for example, right? Both a knowledge graph and a vector database can easily return the answer to who is the CEO of my company, right? But a knowledge graph will outpace a vector database on a question like which board meetings in the last 12 months had at least 2 members abstain from a vote. So once we get into the more complex questions, a vector database is likely to find an answer that's in the middle of subjects within vector space, and not the specific answer that you're looking for. Versus a knowledge graph looks for, it traverses this graph, and then returns precise information based on traversing that graph's connected relationships, okay? So another limitation as well is that vector-only RAG often has poor retrieval results. And what I mean by that is that vector similarity does not equal relevance, okay? Does not equal relevance. So even leaving what was just mentioned aside, the algorithms that are often used by vector databases can sometimes measure semantic similarity, which doesn't always equate to relevance. So vector database retrieval also doesn't come with sophisticated filters, and this can result in many duplicative or irrelevant or even some inaccurate results for RAG. So for example, if you asked, who is on the product management team? A vector database could incorrectly infer that someone on the product management team, that someone is on a product management team because they have frequent commenting access to documents, which is a fact, and then it's produced by the product team, another fact, and then return their name within those results. But because the knowledge graph uses nodes and relationships to identify how many people are in an organization or related, it would only return those specific nodes for that specific question. And then second to last, we have this idea of this lack of explainability and understanding of grounding data. So while vector-based RAG offers basic source citation in your metadata, they don't offer visibility into how and why certain sources are retrieved over others, right? So further, it can be difficult to inspect and analyze your grounding data, which can result in difficult to understand or black box data quality issues that often hinder LLM performance and your ability to improve and iterate over time. So lastly, I'll say about that, vector search is only one piece of the RAG puzzle, right? While incredibly valuable and monumental, vector search likely might not cover all the bases that you're looking for. So Neo4J and GraphRAG in general provides a robust tool set to manage higher quality grounding data, combining vector search, knowledge graph, and graph data science. So just like vector, we integrate with the GenAI ecosystem, including open source frameworks, and we also are open source, like LangChain and Llama Index as well. So ultimately, Neo4j provides some more robust and a more adaptive tool set to deliver GenAI applications at scale. So why use GraphRAG over vector-based RAG? My answer to you all is that you can use both, okay? This is not just an either or situation. You can use both in order to get the benefits of both vector and graph. So, the benefits of GraphRAG in general. People often ask me, why would I use it again? So the vector plus graph approach creates massive improvements for your team's engineering applications. And that includes, one, higher accuracy. So I talked a little about higher accuracy with folk who came to the booth 200, and that is this higher accuracy and more complete answers piece, which is a runtime and a production benefit. So once you've created your knowledge graph, it's also then easier to build. So this is this easier development piece as well. Again, once you've gotten over the hoop of just understanding what GraphRAG and what graph is, it's easier to build, and subsequently, it's easier to maintain your RAG application. And then lastly, a core benefit that people see when they use GraphRAG is better explainability and governance. So you see better explainability, better traceability, because we're being able to traverse the nodes themselves, and then better access control. So this is a huge governance benefit as well. So we're going to dive into these a little bit more. So again, what I had mentioned, and the core piece here, one of the largest benefits of using GraphRAG for context engineering versus standard RAG is this accuracy piece, or the quality of your answer. So this is one example from data.world out of many different white papers, and feel free to scan the QR code that we have here so that you can actually get a copy of this paper and read it yourself. Don't take my word for it, right? Read the white paper. But the white paper found that they have pulled out about 43 different questions, and they found that from that sample size, the average response quality was 3 times higher on average if you use a knowledge graph in addition to vector search. And this isn't new information, right? This isn't new. This white paper actually came out in November of 2023, so light years of time in the development of AI. But it's also a well-known fact that knowledge graphs and the additional context that they provide improves the responses LLMs provide as output for your Gen AI applications. So the second reason that we hear people choose GraphRAG over vector-only RAG is that once they've pushed through this initial hump, this initial learning curve, right, about graph technology and GraphRAG, what we're doing now becomes easier. The development process actually becomes easier. So if we have a phrase, for example, apples and oranges are both fruit. Okay, we see here, apples and oranges are both fruit. If you represent that in a graph space, it's pretty easy, right? There's an apple node, there is is a relationship, edge, that's another word for edge, and then a fruit node. Apple is a fruit. Perfect, right? Orange is a fruit. Pretty simple, pretty human readable. But in vector space, it can look often like this, right? With an actual embedding calculation, or it can also look like several points on a plane. What we're seeing now, we're seeing a little bit of the difference of how opaque analyzing data is via vector space versus analyzing that data in graphical space. So you can also use similarity calculations as well. We're using both implicit and explicit data, and using more explicit methods for structural and then taxonomy purposes as well. So we'll see, based on the similarity of graph nodes, using implicit or sub-symbolic similarity searches like Euclidean or cosine similarity, for example. And then you can then run search algorithms on both the implicit and explicit, but using graph traversals, right? Or more implicit methods like approximate nearest neighbor. So I had talked about that with folk at Booth 200 before as well. So instead of forcing yourself to use implicit and approximate searches, if you add a knowledge graph into your retrieval path, the exploration of your data becomes easier, right? And that's going to lead us to the third benefit of using graph plus vector: explainability and governance. So finally, you're able to traverse the graph and trace the source of an LLM's output, which allows us to better explain the output that LLMs create, which is necessary for auditing purposes, right? Auditing any data process. I love the pictures. I'm gonna wait for y'all. Don't worry, I got you. All right, Nyah. So, I'm talking a lot, but prove it. Right? Prove it, okay? You're talking, but prove it. So this right here is a seminal white paper from a staff software engineer from LinkedIn, Zhentao Zhu, and their team called Retrieval-Augmented Generation with Knowledge Graphs for Customer Service Question Answering, all right? So this paper, and I don't have a QR code for it, but if you take a picture, you can find this paper online and read it. But this paper tested GraphRAG to see if it actually benefited their customer service question answering process, right? And they found that including knowledge graphs into their RAG pipeline, they saw a decrease a decrease in per issue resolution time by 28.6%, okay? That's by including a knowledge graph, an instant decrease in per issue resolution time, which is a significant improvement when we're talking about customer support. Boom, okay. And then we also have another seminal white paper, this time from the Microsoft research team in the office of the CTO, all right, on the benefits of using GraphRAG over traditional RAG for QFS, or query focus summarization with LLMs. This is also a seminal white paper that you should read. Lots of different sources, lots of different proof. But these aren't just outliers, right? There's actually so much research being done on the benefits of using knowledge graphs and graph in your LLM applications to better your context engineering process. So graph and GraphRAG in general, they're becoming really massive now. And it's actually becoming the de facto way that many people and organizations are building RAG applications. And this is because there's so much independent research investigating the impacts that it's having on AI applications. And this here that you're seeing right here, this is just a small sample of that research. So please feel free to take a picture for yourself, or you can go to graphrag.com/appendices/research, also listed there down at the bottom. Excellent research. You can do all your research yourself. Don't just listen to me, right? Prove it to yourself. Perfect. Okay, so overall, there's lots of different benefits for using GraphRAG in Gen AI app development. However, how does this benefit agents? Okay, how does this benefit agentic development? So let's take a step back. I know a lot of us do know this, but for those who don't, what is an agent, right? An agent is an application, if you will, that uses generative AI models to think and act towards very specific goals. So they often automate complex enterprise workflows where you might have rules that aren't very clear and are not easily defined programmatically. So you can then use reasoning and planning to determine the steps to then take next. And you can utilize tools, or function calling for those of us who are developers, which can allow an LLM to do pretty much anything that you can write a function for. So we're going to use that information to then access data and take actions like querying a database or calling an API. So here, you can learn how to do this through what I just call a wrapper around an LLM, and then you'd ask the LLM to prompt in a very specific way, right? So you'd have it start by adding some background context and instructions on what you want it to do, and then you ask it to always respond back in a thought, action, observation, all right, pattern. So we're going to start with a thought. What does the agent need to do? Then we're going to move to an action, take a predefined list and ask it to pick one of several different tools. We're going to then specify what parameters we're going to need, and then we're actually going to take a pause, right? We're going to take a pause in that generation, and we're going to execute whatever tool, either a function call or an API call or a call to the database, and we're going to wait to see what results come back. And then we would feed that information then back to an LLM as the observation, and the LLM will then continue generating. So this is the cycle, right? Thought, action, observation. And this is the nature of agentic applications. So we're going to use the LLM to take concrete actions beyond simple text generation. And then, if we look at this architecture as well, AI agents plan. They do the planning, reasoning, and executing of tasks using target models and tools like function calls and API calls. So the orchestration frameworks, which then allow the agent to plan and execute the process when invoked. I see people taking pictures. I'll also provide this information as slides on our website, Neo4J website as well, right after this. So find us at booth 200 if you need those slides. So lastly, right, this is what the agent architecture could look like when you're also including a knowledge graph. Yes, 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 love all the cameras coming out, take your pictures. So you normally have the agent itself, which is in the teal box, okay? You're then going to allow the UI to expose that agent as a knowledge assistant, for example, with semantic search, automation, and for personalization experiences. Then you'd have the AI model themselves, AKA the embedders or the LLMs. You'd also have the data sources that you would use for retrieval, right? These could be both structured and unstructured data, and that data then gets ingested into the knowledge graph. And then an agent can then access that knowledge graph through tools like MCP, Model Context Protocol, which is right now the golden standard for connecting data and applications to your agent. And then it can also access other forms of source data. So the benefit to agents is that by adding a knowledge graph in the pipeline, when paired with this MCP architecture, the schema of the knowledge graph now provides so much context. When we break down a user question or a prompt, that would then be input into the system, that you start to see very clear and very direct logical flows of information. So if we take this even further, and I'm gonna stop now because we're short on time, but if we take this even further, in some instances, because of this increased context provided by the knowledge graph plus agent architecture, agent/MCP tool architecture, you can even get rid of using vector search entirely for retrieval, due to being able to get that accuracy and that domain knowledge in your agent workflows without relying on semantic search. So again, if you want to do this research yourself, then I would highly advise you to go to graphrag.com/appendix/research. There's lots of different, that's for those who learn by reading white papers. Not everyone does, but if you do, it's an excellent place to do that. But we have information for all kinds of learners. How do I learn more? So one of them, if you like to sit back and learn like this here, we have an online developer conference, which is completely free, happening on November 12th. We always have around 12,000 people who register for that developer conference. We have 170 unique speakers who are talking about Graph and GraphRAG, who are delivering about 145 different sessions. Again, completely online, again, completely free, and the agenda is already up. So you can see some of the most prominent speakers who are coming, including a keynote with our founder and CEO, Emil, and the incredible AI developer and researcher, Andrew Ng, are going to have a keynote session, a fireside session during that event. So you will not want to miss nodes, okay? Another way to learn more is for those who are more hands-on, like myself. I'm an engineer, I'm a developer, so I need to be hands-on keyboard trying to learn these new concepts. So if you want to be hands-on keyboard like me, you're going to go to graphacademy.com. And graphacademy.com is how you learn how to build applications using Neo4j and using Graph, using GraphRAG. All of these, you're going to learn how to build AI agents, all of these concepts, build tools using MCP as well, all of our 4 MCP servers, including our memory MCP server, which a lot of people were really interested in. But that's your hands-on resource. Another hands-on resource before I get out of your hair is our brand new knowledge graph construction course on deep learning AI. So deep learning, also created by Andrew Ng. Thank you. We have a brand new course that has just released and has gone viral, y'all. It's really going crazy. But this is an excellent resource as well to learn more about how to build your knowledge graph and build agentic models using knowledge graph and using graph in general. Feel free to join there. And then lastly, for those who are interested in our Neo4j startup program, we have just released our Neo4j startup program, which will give you up to $16,000, okay? Up to $16,000 in Aura credits to build, test, and run applications. So this is incredible for those who are newer in the startup field, who are just getting started, and who need Aura in order to build out their agentic applications. So lastly, y'all, it has been a day. But lastly, come and talk to us more about your specific use cases for Gen AI and for agentic development and for knowledge graphs. You can find us at booth 200. And if you want to talk more, come find me and I'll be happy to. All right. That is it for me, everyone. Thank you so much. Please feel free to add me on LinkedIn. I'm grateful for y'all. Thank you.